Hello, this is Mr. Best. Welcome to Lesson 8.22 homework. Starting with question 83, assume figure A and figure B at the right are similar. Part A, if the ratio of the similarity is 3 to 4, then what is the ratio of the perimeters of figures A and B? Well, if the ratio of the similarity is 3 to 4, then the perimeters hold that same ratio. So therefore, the perimeters ratio will also be 3 to 4. Part B, if the perimeter of figure A is P and the linear scale factor is R, what is the perimeter of figure B? Well, if the linear scale factor is R and then we have the perimeter of A is P, we should be able to just multiply those two together and take the perimeter of A and multiply by the linear scale factor, and that would give us the perimeter of B. Figure B, sorry. And part C, if the area of figure A is A and the linear scale factor is R, what is the area of figure B? The area of figure B then will be the linear scale factor squared times that. So we would have the area of figure A is A, and if that should be multiplied by the linear scale factor squared, which would be R squared. Question 85. As her team was building triangles with linguini, Karen asked for help building a triangle with sides 5, 6, and 1. I don't think that's possible, said her teammate Kelly. A, why is the triangle not possible? Well, if you think about it here, you have 5, 6, and 1. So if we lay it out, there's a length of 6. I'm just going to kind of lay it out horizontally, and then a length of 5. So as big as it could be would be 11, and it can't be 11, but anything less than 11. And then if you take this 5 and kind of swing it back here, it would line up with one unit left over, but then they'd be laying on top of each other, and that wouldn't create a triangle. So actually, the third side needs to be less than 11, but it needs to be greater than 1. So 1 almost works, but not quite, so that's why it's not possible. And then for B, change the length of one side of the, change the lengths of one of the sides so that the triangle is possible. Well, we could just change the, instead of a 5, 6, 1, we can just change it to something, a little bit bigger than 1. Change it to, 1.5, whatever. Just change that third side in between anything between 1 and 11, and you'll be okay. So lots of different possibilities on that one. Question 86, what is the 150th term in the sequence? Well, let's take a look at the sequence here. We got 17, 16 and a half, 16, 15 and a half. So it looks like we are adding negative 0.5 each time. We're just going down by a half a unit. So that's going to be the growth. So that represents your slope. This is the first term. A sub 1, we want to know what A sub 0 is, or we could use the first term sequence, but most people seem to like to start with term 0, so we're going to work backwards here, and that's going to give us 17 1/2, and that's enough to be able to write the sequence. So a couple ways you can write this. You can do T of n is equal to, you have your initial, which is 17 1/2, and how it's growing, so negative 0.5 n plus 17.5 or 17 1/2. That's one way. Remember, we can use different notation. A sub n still works the same way. These are our explicit equations or sequences. We could also use recursive if that's something that you're interested in. Anyways, these are the equations. We're actually trying to find the 150th term, so whichever one you're going to use, go ahead and plug in 150. And you will find out that term 150 is going to be equal to negative 57.5. And that can be written as A, and then you see that 150. So, there you go. Question 87. Callie started to prove that given the information in the diagram at the right, that line segment AB is congruent to line segment CD, copy her flowchart below on your paper and help her by justifying each statement. So, I said that they were congruent, but I think that's what she's trying to prove. So I'm going to take that out of there. It says that AD is parallel to, line segment AD is parallel to CD, so that's given in the figure. So you can see the markings here. Angle A and angle C, that's also given. And angle ADB, that would be this one, is congruent to CBD, and that would be this one. And that appears that we're looking at the two parallel lines cut by the transversal. So if the lines are parallel, then the alternate interior angles are congruent. So that's why these two angles are congruent. All right, BD and DB are congruent because of the reflexive property. And we know that triangle ADB is congruent to triangle CBD because we have an angle, another angle, and a side. So that would be angle, angle, side congruency. And then therefore we know that, now we know that AB, line segment AB is congruent to line segment CD because we know that congruent triangles mean that we are going to have congruent parts. Question 88. For each pair of triangles below, decide if the triangles are congruent. If the triangles are congruent, 2 bullet points, state which triangle congruency property proves that the triangles are congruent, and then write your congruency statement. All right, part A here, we have angle A and angle D are congruent, so that's a start. We also have two parallel lines, so if we have this parallel line, here's the transversal, and then this parallel line, we also know that alternate interior angles are congruent, so we have that. And then the third thing that we have is we have that this line segment BC is congruent to itself using the reflexive property. So by angle, angle, side, it appears that we are able to prove that they are congruent. So we're going to use angle, angle, side congruency, which means that triangle ABC is congruent to triangle. Make sure you line them up correctly. A matches up with angle D. B is going to match up with angle C. And then C matches up with B on that one. So triangle ABC is congruent to DCB. All right, on part B, we have line segment BC is congruent to DC. So that's a start there. We also have right angle, so there's an angle measure. And then the third thing that we have is we have vertical angles. So this angle is congruent to this angle because they are vertical. So we have an angle, side, angle statement. So once again, yes, they are congruent by angle, side, angle congruency. And therefore we can state that triangle, once again we'll start with triangle ABC and match it up. So triangle ABC is congruent to triangle EDC. So ABC and EDC. Question 89 is a multiple choice question. What is the solution to the system of equations at the right? You really have lots of choices here since it's a multiple choice question. You could plug them into your calculator. You could solve the system. You could take each of these points and plug them in and see if it works for both of them. So I'm going to go ahead and just do the algebra, but like I said, lots of possibilities here. I'm going to take this and plug it in for y since it's already set up for me. So I'm going to say x minus 4 times 1/2 x minus 4. Now some of you might not like that because it leaves the fraction in. I'm not bothered by it. It'll kind of work itself out anyway. So I'm going to go ahead and keep going here. I'm going to go ahead and distribute, combine my like terms, subtract the 16, divide by -1. So I get x equals 4. Well, I only have one possibility, so it's either D or none of these. So let's go ahead and finish this off. X equals 4. I'm going to plug that back into the equation y equals 1/2 x minus 4. So y is equal to 1/2 times 4 minus 4. And so that is 2 minus 4, which is -2. So it appears that D is correct. If we want to verify that, we plug both of those back into the equation and see that it works for both of them. But you do have to plug it into both of them.